Hi, everybody, and welcome to OASES webinar on turning aircraft maintenance records into actionable insights. We have over 150 attendees registered for this webinar, so I'm very excited that this topic generated so much interest. And we have very exciting attendees with us that I'll introduce in a second. So we have a few topics we wanted to cover that we will do in the conversational format between myself and our panelists. And at the end of the webinar, we'll have a Q&A function enabled. So you will be able to ask all your questions there. And if you have any through the session, please put them in. We'll aim to answer them at the end of the session, where we'll put some time for this specifically. Also, you'll see that we'll have a few polls launched through the session, as we're trying to get some information about how you are thinking about these problems to make it a bit more interactive as well. So keep an eye on those. And once they go live, please participate in them because that will give us a good idea on the direction of our conversation. So without further ado, let me introduce the agenda and the attendees. So, the introduction, I'll talk about who do you see on the webinar, and then we'll have a conversation about the aircraft maintenance challenges generally in the space and how Cranfield University research helps to solve those, particularly looking at the maintenance data challenges. Then we'll pass to the OASES Head of Product and Engineering to talk about how OASES product can help to resolve the challenges today and where the product is heading in the future. And we'll wrap up with a Q&A. So today with you, we have myself, Mikhail. I'm a Managing Director for OASES and Valsoft Aviation Portfolio. We have Dr. Fan, a Senior Lecturer in Cranfield University. Just a quick word about Dr. Fan. He's been associated with the Cranfield, which is obviously a prime research university looking at aviation for, believe it or not, over 40 years. Starting all the way as a PhD student, and then leading the various academic programs. He's currently course director for aviation digital technology management, and he has a very wide breadth of research that covers aviation IT, digital systems, and MRO decision-making and agile management, which are obviously very relevant. So welcome, Dr. Fan, to this webinar. We're very excited to have you with us.
Thank you.
And you also have Dr. Abid Al-Zain. He's head of product and engineering at OASES and Valsoft Aviation Group. He also has a breadth of experience across various software applications, and he's been leading engineering teams in a few names that I'm sure all of you will recognize, including Raven and Leonardo, working in defense and aerospace industry. So welcome, Abid.
Thank you, Mikhail. Excited to be here.
Excellent. So with that in mind, let's jump to the topics. And before we do that, though, I just wanted to have a quick note about our partnership with Cranfield. We're at OASES are very grateful to have an opportunity to partner with such a great research university focused on aerospace. You can see in the background of Dr. Fan, this is the plane that they actually have on campus, which is an incredible facility to have and do the research. And we are partnering closely with the university and the academics programs there, helping them with our products and also relying on the insights and ideas that come out of the research programs run at Cranfield. So we hope to see this partnership continue and very excited about it. But let me turn our attention to the first topic of the conversation and maybe start relatively high level. Dr. Fan, the first question to you will be, when you look at the maintenance aviation space currently, what challenges are you seeing in general? I know you have a couple of slides, so maybe I'll switch there and pass the mic to you to really set the scene on the space as you see it.
That's great. Thank you, Mikhail, for the introduction. Just a little bit of the scene setting. So the slides that I'm going to use this morning is actually the result of one of our MSc student group project. So I'll elaborate a little bit on as we talk about the research program. But part of the background research, I think it is not a surprise for most of us who are watching the industry, is that the fleet is at the same time being regenerated, but also aging, with a lot of the suppliers not able to deliver the aircraft at their promised rate. And so coping with the post-pandemic demand, we actually have to keep a lot more older aircraft in service. And some of those we even bring back from retirement to fit it. So that become an interesting dynamics. And this is going to go on for some years. And on the commercial side of the business, we always now have the cry for supply chain disruptions, park stoppages, turnaround times, etc. Arguably, this has always been with the industry, depending where you sit in the food chain. However, what is making it more prominent is that with the aging aircraft needing more parts, the newer aircraft, unfortunately, need even more replacement faster than they were planning in the original plan. And so the whole supply chain manufacturing demand is needing time to catch up. We all know about the workforce shortage. This is the kind of things that's published regularly. And for the people who are in the meeting today, and we have a scan of the attendees that in the relevant industry, some of the major American and European operators are starting up the new academy to train technicians and pilots because of the need for demand. So this is also one part where we have to pay a lot more for the people and keep the people in the work. With aircraft getting older, then all these become something that is very demanding for us to be able to fit the maintenance. I would say this is a broad picture that we see as challenges, but at the same time, it would be useful to put it into context that all these headline items are things that we have been complaining about, but for some reason after COVID, and as the travel demand, cargo demand begin to increase, it come to a much sharper head. And so it's going to be an interesting to navigate, and it is really likely that we will be in this situation for the foreseeable 5 years, if not longer. So something have to happen.
Excellent. Thanks, Dr. Fan, for this overview. I think it's interesting to see how the industry evolves and how many challenges are thrown at us. I think we're living through the very interesting time, particularly this year, when a lot of macroeconomic scenarios overlay on top of what already were the bottlenecks in the supply chain and in the fleet being refreshed. I wonder, like, what are when you speak to the airlines and MROs on a practical level, like bringing us a level down from it, like, what are the biggest challenges they're facing today around the maintenance data that they have?
Now, I think this is a very interesting question. So thank you for bringing it up. Part of the understanding that we need to put, and as Mikhail say, I am very old, so having that opportunity to see the trend is that on reflection, the way that aviation is looking after maintenance and it is in the correct safety context. But the practice of continuous airworthiness, as we know it today, is very much designed back in the 70s and 80s, in the days where we primarily rely on pen, paper, and people. And so it is going to be pretty paper heavy. And so that's where one of the thing where when we are short of people, we may want to use people more to do the work rather than to throw through records or keeping records and filing records. And when we are short of components, it's much better than we can optimize where to locate the component when they are used. When on one hand, we cry that we are short of parts. On the other hand, we also have some spares in some bits of the warehouse that we forget. So all these in terms of being able to exercise better control is part of the picture. Is it the biggest problem? I would say maybe we can learn from outside aviation. So for a long period of time, my role also worked with the manufacturing industries. I would say 20 years ago, when the major manufacturer bring on enterprise resource planning system, lean manufacturing, total preventive maintenance, quality maintenance systems, etc., that some of the situation that aviation maintenance is going through draw a lot of parallel. So if you have the chance to look across and bring some of those components and ways of using, it is going to help. And one important bit that we can actually bring across is the way that in a good manufacturing organization, they have actually removed a lot of their paper processing and get into automated system. However, when Mikhail asked about the challenge, it is, I would say, the mindset, because we have been doing things like this for so long. It's very difficult to rock the boat, and most of the people will say that we can't change because the authority will not allow it, and it's a huge expense to get the approval. And that psychological mindset perhaps is the biggest challenge. Whereas while in Cranfield, we have opportunity to work with some of the authorities, they are not actually adverse to the use of technology, but we need to engage them in the right way at the right time. So if you look across, one of the important thing in that changing point is that digital technology is now cheap and a lot more readily available. And with most of our workforce, not because of work training, but because in their daily life, they're much more using their mobile phone to do various things, the fear of technology is eroding very quickly. So it become a lot easier for us to bring in those technology. So there's that mindset hurdle, but also the change in the digital acceptance in the wider society. But also very exciting is that the newer generation of aircraft, so we're talking about from the 787 onwards, the MAX, the NEOs, and a lot of interesting things happening in the business aviation sector, that we have a lot more intelligent systems on our aircraft. They can tell us a lot of things. So for some of the published information that you can read, a transatlantic flight, the engine are generating about a terabyte worth of data. So, and if you are going to buy a new aircraft, I've just bought mine, well, joking, not exactly, but I was kind of exploring. If you go to talk to Airbus and buy a new 320 or 330, the built-in system will offer you a choice of up to 34,000 lines of data that you may be able to receive information on the ground for real-time monitoring. So this real-time sensor availability is becoming huge. And in the last 5 years, the whole theme around predictive maintenance had been taking off. And so there's all these opportunities happening. But whether we are ready to use it and how we're going to use it and whether which level of technology is right of us become the interesting differentiator. So when we prepare this slide, it's very much to let people know that the digital capability is a range. It's not one thing, which unfortunately the public press seems to simplify it too much. And it's out of that range that there are people with a large fleet that can go to Skywise, HM, Aviator, etc. But for smaller operator that may not want to spend that amount of finance or do not want to have the tie-in with some of those service provider, they are also sitting on records that they can take advantage as well. And the work that we do in what we are going to explain more is very much in the context of this, how do we take advantage of this massive volume of maintenance data that historically we have accumulated for the basis of compliance. And now perhaps we have a cheaper and easier way to take advantage of the insights that is buried in the information that we had. It's not a new thing. It's about, again, 20 years ago in manufacturing, where the major ERP manufacturers were trying to sell people the notion that data is the new gold. because if you mine its sufficiency, that's where you can extract value. It's just that aviation have been a little bit slow to catch up on that.
Yeah. No, thank you, Dr. Fan. Congratulations on your plane order as well. Let us know when it gets delivered. We'll come around. One thing that I think struck me as the inside of the event that you and I've been together in London recently is the conversation around data that concluded that the data was always there in aviation. It just was really difficult to extract any insights. So if you were to like summarize what are the number 1 and 2 challenges, let's say, for how can we that don't allow the aviation businesses to extract valuable insights that they can drive their decisions from these enormous amounts of data that everybody is sitting on. I think that will make it like very practical. And while you're thinking about it, I wanted also to ask the participants to share their challenges. So we'll launch a poll in a second. And what will be fantastic to hear is what are your biggest challenge when working with aircraft maintenance records? We'll have a few options for you, and I'm really interested to see where it turns out. But over to you, Ken. Dr. Fan, so like if you were to say about the number 1 and 2 challenges, what is your take on that?
I would consider the poll is now on screen. I hope the delegates also can see that. To me, the number 1 is turning data into actionable decisions. That would be the number 1, and all the other 3 sit underneath it. But then I am jumping the gun on the poll results.
Yeah. Right, you're skewing the results, but let's see what they turn up. Look, I think this is a good opportunity for us to talk a little bit more about the research that you've done recently with Cranfield. Maybe you could introduce the project that one of your teams has been working on and the research that they been focusing on, because it's very relevant for our conversation.
Yep, that's good. If you can move to the next slide, that can help me to put the context in place. So for those delegates who have not known about Cranfield before, we are a specialist university in the UK. We are about 80 miles north of central London. And it is a university that born out of the Second World War effort. So the Ministry of Defense acquired the farmland on top of a hill and built us as an Air Force base, focusing on a light bomber support to prepare for the Second World War effort. And after the war, we were selected as the place to help in jet engine-powered aircraft research and development. So over those years, currently we still have an active airport with a 1,800-meter runway, so just about able to land a 73 or 320. We also do all sorts of other business jet and general aviation activity. And around the site was built the research center, and then it became the airport and the aviation university in time. So some of the people who know us from longer history may know us as Cranfield Institute of Technology, and then we changed name to be a university to make it easier to understand 20 years ago. As part of what we have is our National Flying Laboratory research. So the screen show one of the aircraft that is a main flying aircraft. Is a converted sub 340B aircraft that is a flying classroom, and the seat is reorganized in a way that the seat back of each of the seats, where we normally have the TV screen, is a specialist computer that can replicate some of the instruments in the cockpit. And one major use of the aircraft is students who study aircraft design, aerospace dynamics will be taken on flights in various test patterns. So from the theoretical knowledge of aeronautics that they learn in classroom, they can have the body experience of how it feels. So when the pilot put it in a 2G turn, it is interesting. but they also read the data so they can correlate the data with the experience. So it's something that we have used as a concept in our beginning, using earlier generation of Royal Air Force aircraft. And it had been a Jetstream 31 for a period of time, and then it became the Saab in the last few years. So this is one of our aircraft. We also have two smaller aircraft, a Bulldog and a Slingsby, to do aerobatics work, as well as instrumentation and development. Behind me on my screen is actually outside my office. That is a retired 737-400 that we use as a ground demonstrator. The interesting thing that we have in these assets is that for the 73, I have the complete maintenance history in records form as well as in the plan since its inception and enter into service with British Airways. So it's 20 years worth of it, 108 boxes, which is the second bit of the photo that we keep. So for us, understanding that ground reality help us in our research in turning the records into something that's useful, but it's also a great training material for us to help people to have hands-on experience. So it's not just talking about it or maybe writing software in a lab, but actually having to work through the record as the cases and say, does it work? So that is the nature of Cranfield, and something beyond what I have on the screen is that we are the lead trainer for accident investigator in the UK and many parts of the world. So when the records are being used as evidence to support accident investigation, how they are relevant and important, and the importance of the accuracy of that is also part of our thinking. So the back end of all these is that within the Cranfield environment, we have access to all the industry records, ways of working to give us the opportunity and set the ground for what can we do about it? How do we use these assets to generate the insights? And I mentioned, Mikhail mentioned that I am the course director of the Aviation Digital Technology Management. In that 1 year MSc, one of the components are the group project. And for this current academic year, we set a group to work on these records and say, what can you do about it? And I'm very pleased that the 4 people in this project team has joined us as well. So Sarah, Hannah, Hoya, and Sadia is with us. So if there are any hard questions later on when we explain the project, I will refer to them. But shall we look at the poll results now, Mikhail?
Yeah, no, absolutely. Thanks everybody for responding. We've got 35 people engaging, which is great. I think will come as not a surprise that turning data into actionable decisions was the #1 challenge faced by the practitioners in the space. So very much in line with your tip before the poll started. But the second one is the data spread across multiple systems is the challenge. And I guess, even if you're using digital records, you will still have some paper records, which, I guess you can also count as systems. So I think was one of the challenges that the team has been facing on the project is how do you actually turn this information that is so spread across multiple ways of recording into something that could be turned into the insights, right?
Indeed, I think the multiple system is also the fact that a lot of operators may use different MRO houses in the sequence of checks during the life of the aircraft. And so the records coming back from the different MRO houses each have their own flavor of their own system, makes the harmonization a very interesting challenge.
Yeah, definitely. So shall we look at the results of the project? I know the team did a great job and has some few visualizations that we can demonstrate. So maybe as we do that, you can kind of talk a little bit more about what are the challenges that the team discovered that haven't been solved before, and what are the gaps that were identified in the team as they were going through these mountains of data and trying to turn them into the insights through the project.
Yeah, that's great. So before I come to the visualization, I'll explain a little bit about the history of the aircraft and what the team had done. The sub aircraft itself actually come into service about 20 years ago with Mercerba. And for a period of time, it was flying as a commuter aircraft over in North America. And at some point, it returned back into sub, and then we acquired the aircraft and then put in modification to make it into our flying classroom and operate it. And in this journey, when it was with Mercedes, it was using their historic MRO system, which is, of course, very accurate and compliant, FAA, etc. And that worked for a period of time. When it returned to sub, then it go into the system that sub use for their CAMO operation. And again, it's all very good. So this is the scenario where our pole point around data spread across multiple systems also happen with this aircraft. And it's also the transfer of ownership that may be very representative when a leaser take the aircraft to different leases. And after it was converted in sub, initially, Cranfield used sub as our CAMO because that's most logical and convenient. We only have one of them, so it's no point for us to set up a CAMO service, just look after one aircraft, and sub can do that. Unfortunately, Brexit happened, so we cannot have the sub to look after the aircraft on a UK license. And so we have to move the CAMO of the aircraft to Logan Air, which at that point of time was operating a fleet of sub 340. So it's convenient for them to give us the maintenance service and the CAMO. And then in time, when Logan Air retire all their 340, then we have to find an alternative provider to do our CAMO. And it's very good that Avalon have the use of one of the hangar in Cranfield, and they also have a CAMO service. So that moved to the systems that Avalon use. So when we were looking at these challenges around the problem that data spread across multiple systems, and also free text maintenance records, they are all part of the history of the records that the student team in the project have to tackle. They are a very clever bunch of young people, so they were dissecting the nature of the different data and record. And there are some of the record in handwritten form without hard form, then some kind of image processing, OCR record, plus handwriting recognition, plus manual eyeball work become the tools that they use. There are records that come off an established CAMO system, then they were able to write translator script into translating them into a more readable form of Excel spreadsheet, a mini database that we can do analysis, and then combining them into the history that we can begin to see. So what is on the visualization now is an overview of the records that they have. Because they only have 4 months to work on it, we do not have time to churn through everything in the history of the aircraft. So they were sent to focus on the history when Cranfield owned this aircraft. And out of here are the understanding of the different flights, the different record. And from the record point of view, begin to go into the text and analyze what actually are in the records. Are there patterns? One of the tasks that we will specifically focus on is to look for components that may fail a lot, that link to our supply chain industry challenge. They also were tasked to look for ways that the findings, the non-routine card records, were triggered and handled, because that is a big part of the uncertainty that will delay a check and reduce the turnaround time. So the screenshot that we have is a summary of the database that they had built after they have done those records processing.
Excellent. And maybe we can talk about like a specific insight based on an example of the problem that they were trying to solve, right? That has a direct link with the decision making.
Absolutely. I think this is one of the examples that they have find out there are more within the pack. And the example that we bring out is that in the records, there were a number of incidents where the nose landing gear lamp need to be replaced. Now, if we think about it as a supply chain problem, then taking the top left cloud bubble, then perhaps it's an indication for us to prepare more spare lamps. So when we need it, we can replace it and return the aircraft to flight. So that is an immediate first response in terms of maintenance action. But as we were able to drill into the records and we begin to see the pattern, and the pattern not only in the non-recurring card, but correlating with the tag log entries that identify things were not necessarily well, and we can do the analysis to correlate what flight and which airport that it landed to. Then we begin to open up opportunities to do more problem solving and detective work. So in this particular case of recurring defects, I can't tell you the exact solution because then my CAMO team may beat me up, but we can go through that investigation route as to perhaps that we need to have a shorter component replacement interval. So is it because it's something else in the system? For argument's sake, the lamp draw power. If the electric system feed too much power to it, it may shorten the life of the bulb. So rather than the bulb need replacing, it may ask us to do a more detailed investigation into the electrical and the control system that is related. Or if we have been buying the whole batch of lamp from the same supplier, is it a supplier issue that we can have to understand and work out and negotiate with the manufacturer? The other side is that perhaps is it something to do with the airport or the particular flight profile that is used, so that the lamp is exposed to more likelihood of ground fault damage. And so the fix is actually improving our pilot instructions rather than to deal with the engineering. By having the information at the back that we can correlate with the different situation, it gives us the opportunity to go to the root cause of dealing with the problem and take it out once and prevent other situation. And this will be one important part of the notion of insight. And it is not only the fact, oh, we now understand the pattern of the spare parts that we need to buy, but the opportunity to go into how we use aircraft, how we look after the internal system, the additional check that can avoid this becoming a problem. And to me, this is a significant part of preventive maintenance, predictive maintenance, whatever you want to call it, that we do not need to rely on onboard sensors, but with our wealth of record, we can do things to improve our operations.
Excellent. I think this is a great example of how academic research can translate into real-world application, right? We look at the focused case of an individual part and how the data can lead to decision-making. So hopefully that gives an insight to the attendees how you can also look at the data that you are storing and have a focused analysis around it, particularly the critical elements where you see the inefficiencies, and try to start creating a decision tree similar to what Dr. Fan has demonstrated, and challenging how the current decisions are being made. Are they actually leading to the right outcome, the right stock levels? So thank you, Dr. Fan, for this overview, and congratulations again to the team for doing a great job on this project. We have another poll that I'd like to introduce at this point, and then I'll pass the word to Abid to talk a little bit about how we at OASES support data-driven maintenance. So before we do that, we'd really like to understand how is your organization currently using maintenance data? So again, the poll will come up on the screen. You'll have a few options to select from, and we're really keen to see the results. But for now, thank you very much, Dr. Fan. Excited to have you with us, and please hang on until the Q&A. I'm sure there will be a few questions thrown into the poll. To the attendees, though, please take the advantage of the Q&A function. And if you have questions on the research or on the next piece, don't hesitate to put them in. We will address them at the end of the session. All right. So with that, Abid, we'll pass the word to you. And what we'd like really to understand is how OASES is supporting the maintenance decision based on the data today. And maybe you can also give us a little bit of an insight of what the future holds.
All right. Okay. Well, thank you, Mikhail. Well, it's the most difficult bit when you give a talk is you give a talk after some good talk. So I need to keep up the rhythm and the level after Dr. Fan what he presented. From an OASES point of view and what we try to do here, and I think as Dr. Fan have laid out to everyone, the problem is not the lack of maintenance data really. The gap is the data often is fragmented, as you highlighted in the few slides earlier on. And then how we're going to get all these together and how we can bring that inside from it. And that's where OASES come to help, either with CAMOs, MRO, or airline teams to find that relevancy. So if we go to the next slides, what you see here is, the pressure is not, as I said, in the data volume itself, but what we're trying to do to achieve here is how can we link all these data together. So OASES, you look at OASES as a system, really, and it has data which coming from airline, from CAMO, from materials, from MRO, and at the moment, or just previously, the data was stored as fragmented pieces. And what OASES is trying to do is to find a relevancy between these data, and that's then give you every different role within different organization the ability to interpret this data in much better way. So then the idea of understanding what is going on is much simpler. The data is there and the question is there. But normally, because these data is fragmented in a way that is not easy to get them, link them together, and that where you end up, there is misunderstanding. And what we're trying to do here is how to capture this information all together, all this data, and link them in a way to make it available to anyone. Was it an engineer working in a maintenance, or an airline trying to understand the availability and the airworthiness of their system? So if you go to the next slide, you see how we're trying to go through that volume of data. So you talk about, all right, we're going to get all these data together. So how OASES can help us to deliver this? And that's the big question we have to answer here. So we need to create a trust in the data. So in some cases, the data itself, it need to be going through certain process to make it more reliable. That data, the data is trusted in a way it can be added, it can be used in a system which is able to provide the correct informations to the users, and that then create the flow of the journey, whereas you can see the data is used by MROs, by different by different existing system, and then speed the process. Then that's create and foresight, and you're able then to see, explain, understand what is going on, and then you're able to scale. And that's where we need to focus on how we can scale that system to be able to talk to more data and more aircraft and more maintenance, and able to see what you need to achieve quickly. So OASES give the customer that structured system of record, so the information is captured, connected, and available when it's needed. So if we go to the following slide,
Yeah, Abir, I just wanted to recognize the responses to the poll that I think are very telling, given the challenges that we have been talking about with Dr. Fan, and now as we look at the roadmap now and how OASES can support the organizations. The two main uses of data right now that the attendees highlighted is, number one is mainly reactive reporting, and the second one is dashboard and KPI. And when we talk about predictive and advanced analytics, we have only two responses of those. So that's telling really where the industry is right now, and I think underscores the fact that having the data in the right way is still the key to the main users. And as we go along, hopefully we can take the industry on the journey as well and move them more towards the foresight and how we can use data, not only looking backwards and reacting to what we already have, but how can we make decisions going forward, relying on our historical records that give us insight about the future.
Absolutely. So I think if you focus on that and the result, it gives you that insight. For years, the data was recorded in a fragmented way, really, and then we moved not to a digital system, I think, to paperless system. I think that's my understanding when I look at like what is happening in the industry. People thought, okay, if we stop using papers and we start using record is stored somewhere in a data center or in AWS or Azure or somewhere, or we have a digital system. Actually, no, what we have there is a paperless system. So the data is just electronically stored, but the data is still fragmented. And that's what we need to move away from. We need to get that data is not only electronically stored, but also is connected. When you get that connection between the different parts of the data, you're able to have an in-dimension model of the data, and then you're able to answer difficult question, which actually everyone trying to answer these questions. This question could be to understand predictability about the component in the system, or you understand the airworthiness of the aircraft, or how do you spend your budget buying like materials in the stock. That all comes by creating that interconnected model. And that is what we call a digital system. And that's what OASES is trying to offer all our customers. And I'm going to repeat this, is not a paperless system, it's a digital system where the data is connected. When you connect the data, you find a meaningful connection between one part and other part of the system. And that's where you can see the foresight, which I highlighted here in what we're hopefully by 2028, clearly there, but also you're able to scale. So then your understanding grow and you add more data. So you're more understanding and more data can be added to that model. Based on this, you can use AI. I think AI, and everyone knows, is available, but the problem, the AI is not going to help you unless you get that data is connected and enable AI to understand it and make sense of it. So so now to reach that point is we need to go through a few steps. OASES as itself is a system, I look at it, and the system has multiple components, and you cannot build a system in isolation from that eco-environment where it's happening. And whenever you try to boost one part of that system, you need to see how you're going to compromise other part. There's no system can work in 100% in every aspect. So to reach that point, which we can able to connect so much data together and create that visibility and get information, we need to see how we can create that process. And the process is started by reducing the workflow. There is less frictions between the different material or different data coming from different parts of the system. Then when that process was becoming clear and our customer will see this happening when they start using OASES, then you can see the data confidence is higher because you could understand, all right, and I can see now how the data is validated because it's connected with other part. In isolation, it's very hard to I say, okay, this makes sense or doesn't make sense. So every time you add more data and the process is much clearer, the confidence in the data become clearer. And then they allow you not only to search for something, but also you can see how that data is important. So you look for something, that connected data is always available to you. Is not a system is just like a search, more than give you an information, and that information is becoming more automated. And that when you can see the first wave and how we strengthen the core of the system, and that's when OASES will show you how this strengthen your understanding of your data, and your data become more visible to you. And that's take us to the next stage, which is, all right, now I connected all these together. So what does that mean for me? So how is it going to benefit me? That will benefit everyone, really, from mechanics who need the right information where work happens, to engineers and CAMOs need to traceability and technical context. Planners need a clearer view of what is coming, and management needs confidence that decisions are based on reliable information. That is the model, is what you're going to get when you're using this system. And that is where the system is becoming more connected and have a trusted context, which enabled everyone to use, and then is giving you that confidence. What you're trying to use and how you're going to achieve and deliver is much clearer. If you go to the next slide now, you will see that this is the journey we're trying to capture here. You know, the system is all connected with each other, and the information is much clearer and structured. And I'm going to back to my statement earlier. I said it's not a paperless system; it's a digital system, where is everything connected. However, we're not taking the human element out of it. What happens when all this data get connected? It gives more confidence and more human amplifier to the users. The user still has to be there. Human in the loop is very important. We are a regulated business, and we're not going to let AI to make the final decision about this part has to be maintained, so it has to be replaced, or the airworthiness of the aircraft is happening. Human in the loop will be able to see what's happening and make that regulated judgment. But AI and the data all connected with each other give that confidence and that decision to the user of the system. So the journey is becoming clearer. You capture the information, you structure it, you connect it, and across the operational, and make it visible in a way that support actions. So OASES is the platform that enable that journey. So if you go to the last slide, and you can see here the following slide. So what we need to tell the story here is the future, how we're going to get all these shaped together. So the technical logs and non-routine cards and work orders component, and all this history things about how the aircraft being maintained is all part of that story. And that story can be bring to the customer through OASES. Will make all these components working together and allow you to see how you do full traceability for your system. You can create accountability and validation, and that's make you make a better decision about what I need to do next. It's not a system to record your data as much as a system helping you to make a correct decision using evidence, because as I said earlier on, a human will be in the loop. Also, part of that journey is the mobile. So I hope that we can have more time to talk about it, but the mobile journey is very important. At the moment, we do maintenance. Everyone using a phone and a tablet, and that mobile journey will be part of that. So the data is available in your phone, in your tablets, and what is needed is stored there. And that is what the journey going forward for OASES. Thank you.
Thank you so much, Abid. That was very insightful. I think with that, we conclude our webinar content. I think what we heard so far is that from both Dr. Fan and Dr. Al-Zain, that there are a lot of challenges in the industry right now, with the maintenance records being stored across the systems, with the supply chain being constrained, with the growing demand is not really met by the expanding fleet, and all that put a lot of pressure on the maintenance. While at the same time, we see that the data is very dispersed. There is no lack of data, but the industry hasn't really crossed this curve when they are able to use the information effectively to predict the decisions. And that creates inefficiencies downstream for their supply chains, for their stock levels, and for how they are doing the maintenance. And so hopefully you do see that the digital systems like OASES do help to solve these challenges. And we are moving our roadmap ahead as well from just getting the digital system in place and being the system of record to helping to predict those. But there is a future that we'll need to build together with the practitioners in the industry. So we want to open for the Q&A, and I want to thank again Dr. Fan for participation in this webinar. If you want to get in touch with him, here's the information in terms of his email, LinkedIn profile, and you can find him on the Cranfield University website as well. So thank you again, Dr. Fan. If you want to hear more about OASES and have a conversation with our commercial team, if you're interested in the system, you want to learn more, have a demo, understand how it can solve the challenges that you have in your operations, please get in touch with us. You see Jan and Percy here will be really happy to help and walk you through the product that we have. But for now, let's open up for the Q&A. There is a Q&A function if you haven't used it previously. As you can see, one question from Lokesh. And let's see if we can answer it. So the question is, how is the challenge coming when moving away from the paper-based maintenance data to digital copies when talking about component certification? Differentiation from forced certification to genuine. Abid, is something that you'd like to answer?
Yeah, I can answer that one. So it's a great question, really. The shift from paper to digital for component certification is addressed through the digital e-signature we have in OASES, which are protected against forgery by multiple layers of verification and security protocols. So, and that will differ from how the paper-based certificate digital signature provide a clear audit trail and significant harder to tamper with. I hope that answered the question.
Yeah, thanks Abid. I think we have a lot of hopes on the e-signature as the functionality that can really help to improve the quality of data that is being fed. And I think that's what Lokesh's comment is about, that the system can only be mistake-proof if the data fed in is high quality, and that's exactly what the e-signature technology would hopefully allow us to do. If there are any other questions, this is the time to ask, so please don't hesitate to put them in the chat. And if there's another questions that you want to discuss at this forum and you want to talk with us individually, you have the contact details on the slide to get in touch with us. One more comment. How are you planning to project maintenance records for aircrafts with future technologies and emerging technologies? For example, eVTOLs, and when they're used for urban flying in large scale. Who wants to take a crack at this one?
Okay, sorry, I've been pressing the wrong buttons and probably confused many people. Yeah, that is a great question. Preparing for eVTOL is going to be a very significant part. I would say it depends on the journey. So and where we sit. If it is people from the OEM side creating the whole CAMO system as well as the supporting system for the vehicle, is going to be very interesting. There are a few things happening with the CAA and authority around the regulation bit of that is coming along. But if we are going to have the record right from the beginning, and that's the exciting bit, that the OEM can actually set up the working system from the beginning, that they can get the information directly from the aircraft and track the use, etc. The component feeding in, which is the inbound logistics question that was earlier, again, become a lot easier because the new supply chain that is being set up to use. So I would say if it is the OEM and the core bit that is creating the system is one of the most exciting thing in the aviation industry that we have the opportunity to start from scratch. If we are the user end of the system, life can be a bit more complicated because we have an ongoing business, we have an ongoing system, and now need to look at these new vehicle that may demand us to do different things. How that piece of integration work, I don't think there's any standard guideline. We probably have to take it on a case-by-case basis. But it's going to be really interesting. I fully believe that we should have urban air taxi around New York and Miami sometime in 2026.
Thanks, Dr. Fan. So there's a question from Sagar in the Q&A section that Abid answered. We're getting close to running out of time, so I think maybe we can.
Something in chat from Ian as well.
Yeah. That's what I was going to.
Right.
Oh yeah. So Ian's question is, any thoughts on how the data can provide insight without having to be prompted with the search type question?
That's the answer I wrote in the chat. I think I need to see the other Sagar question.
Okay, great. So Sagar's question, what are your thoughts on full operational digital twin model to identify any failure before it comes to the shop floor for maintenance to increase the time on wing if we talk about aircraft engines? Dr. Fan, I don't know if you have.
Yeah, it depends on the engine. So if you are using some of the commercial Rolls-Royce engine with the Trent and so on, the total care package have a reasonable capability for most of those, and you'll find something similar from the GE range of engines. If we are looking at the perhaps more the regional commuter jet that use the older generation of engines that do not have the sensor suite, then you may not have as much real-time feed information on it, and it would be primarily working through the records and the inspection check. One of the things that I feel having around a bit of time is that often when people do their line check, the information is filed and never really used to do trend plotting. So that is a potential where we can actually not only file the record for compliance, but also have it in a form that we can observe potential gradual degradation and use that as a basis to plot. Digital twin is an exciting thing. I haven't seen any really fully working operational digital twin totally yet. But the value when we can get to that is not only to do trend plotting on one part, but to use the capability, if it is a right digital twin, to understand how the different parts work together as a system. So we will be able to detect system level faults and how something on a small component can propagate to have much bigger effect and trap it when it is small. So if that happens, that's great. But at this point in time, I haven't seriously seen anything in the commercial offering that can do that job yet.
I can add a little bit. I did work with digital twinning before, and look, it's a very complicated topic because you need to have so many parameters to be plotted into the system to get a real digital twin. Most of the, even in energy and some critical sector, they try to use digital twinning, but for very, very small component to understand their behavior. A full engine or some in that scale, digital twin I think we don't have the computational capacity to do that at the moment. It's physics. We're going against physics at the moment. Or if you have something, it wouldn't be reliable to use.
Great, thanks for your answers. I think given the time, we'll start to wrap up. So thank you everyone who joined us. Thank you for your engagement, both on the polls and on the Q&A. If you have any more questions or you want to discuss further, either research at Cranfield or OASES, please get back in touch with us. We'll be very happy to follow up with a separate conversation. But so far, thanks again to our panelists. Dr. Fan, pleasure to have you. Dr. Alzain, thank you for the presentation. And we hope to see you at the next webinar. So keep an eye on the further announcements from us.